Here we have a system of equation, and we want to solve it using matrices. So we're gonna write down first of all as a non-augmented matrix, so as matrix M, which is gonna be 1, -1, 1, 2, 1, -1. Oops, write it better. And then 3, 2, 2. And then our augmentation, let's go like that, is going to be the numbers. So 4, -1, and 5. Now, first thing we want to do is find the determinant of our matrix M. So the determinant is going to be something like this. First of all, let's take this and copy it over here. And I want to play with it a little bit. I want to simplify as much as I can. Let's see what I get. I want to do row 1 plus row 2. And then row 3 minus 2 times row 1. So, actually minus 2 times row 2. So row 1 plus row 2, we get 3, 0, 0. And then the second one remains the same. The one becomes minus 2 times row 2, so we get -1, 0, and then 4. Now, as you can see, we can use Laplace's development, so we can see that the 3 over here is in a row where there's just zeros over here. So we get rid of these numbers here, and we obtain, since 3 is going to be a plus, we can simply write as plus 3, and then the matrix that is left is 1, -1, 0, and 4. So it's going to be plus 3, and then 1 times 4 minus 1 times 0. So we're going to get it 12. Now, in order to find and that's the determinant of our matrix M. Now, when we want to use the inverse, we're going to have to do something very particular. First of all, let's take our initial matrix, the one that I just contoured, and let's do it. And then we have to find something very similar. First of all, we're going to have to take the first element, cancel out the other 2 rows, and find what's the determinant of this number here. So we would have something like 1 times 2 minus 2 times -1. And since 1 is the first position, it's going to be a plus, so here it's going to be a plus. We're fine for it. The second position will be a minus, and the second position is this -1 over here, so we're going to do something like this. So the determinant of this will be something like 2 times 2 minus 3 times -1. And then we have the third row, first a third column, first row. So as you've already understood, this is going to be a plus because it's the third element. And then we're going to be a 2 times 2 minus 1 times 3. Then second row, second column, we're going to have a negative in front, first of all. Then -1 times 2 plus 1 times 2. Then second one, we're going to have a positive, first of all. And then 1 times 2 minus 3 times 1. Then we're going to have a negative. And we're going to have a 1 times 2 minus 3 times -1. Now, for third row, we're going to have, first column, we're going to have positive. And then we have a -1 times -1 minus 1 times 1. And then negative for this one right here. So we're going to have a 1 times -1 minus 2 times 1, and then positive again. We're going to have a 1 times 1 minus 2 times negative 1. So if we solve this, and this is all going to be a matrix, we solve this. From the first one we obtain a 2 plus 2, and then we get a negative 4 plus 3, and then 4 minus 3, and then we do negative 2 plus 2. Oh, here it's going to be a negative in between, of course. So, negative, sorry, no mistake. And then a 2 minus 3. Yeah. Then negative 2 plus 3. Then here we're going to have a negative 1, and then 1 minus negative 1. And then we have a negative 1 minus 2, and of course negative in front. And then a 1 plus 2. So let's rewrite it. We're going to have 4 over here, minus 7, 1. Then we write everything closer together. So just get to see it in a single look. Then 4, negative 1, negative 5, and 0, positive 3, and 3. Let me get this closer. First one and this one. Okay, okay, and this is our final matrix called C. Now with this, we have to find C, the power of T. So we're gonna have to invert the function. So the first row will become the first column will become the first row. So we're gonna have 4, 4, 0. The first column will become the second row. So negative 7, negative 1, 3. Third column will become third row. So 1, negative 5, 3. Oops. Now with this, we have to do 1 over the determinant that we found before times C, the T, and then times K. So we're going to have a 1 over 12 times this matrix that we just found, that I'm just going to copy and paste over here. Okay. And then K, that we said before, was 4, negative 1, and 5. And it goes down here. So this column, again, we can see that the first one is a 3 by 3, and the second one is a 3 by 1. So the final one will be a 3 by 1. So we're going to do this. We're going to have 1 over 12 in front, of course. And then the first row will be 4 times 4, because we take this one and multiply by this one. Then we take the second one and multiply by the second one. And then we do the third one and times the third one. So we're going to have 4 times 4, we said, plus 4 times negative 1, plus 0 times 5. That's the first row, only column. Then we're going to have negative 7 times 4, plus negative 1 times negative 1, plus 3 times 5. Then 1 times 4, plus negative 5 times negative 1, plus 3 times 5. So let's solve what we have in here. We're going to have a 4 times 4, so 16, plus, actually minus 4, plus 0, so we're going to have a 12. And then the second one will be negative 7 times 4, 28, plus 1, plus 15. So we get 44. That's what you should get. Let me check again. 16. Okay, yeah. And then 4, and then plus 5, plus 15. So we're gonna have a 24. And don't forget the 1 over 12 in front. So can we simplify the whole thing? Probably. Let's look at it. We're going to have 1. Let me make sure I'm doing everything correctly. I don't want to mess up even like the smallest thing is going to create the biggest problem. Oh, I forgot. Negative 28. That's what was. Yeah, so we're going to have negative 28 plus 16, so 12. And so, sorry, negative 12. So negative 1, and then 2. And these are in sequence with x, y, and z. So x is going to be equals to 1, y is going to be equals to negative 1, and z is going to be equals to 2. And that is our final answer.